Okay, this is the notes for section 8.8, arc length and circumference. If you haven't done so already, make sure you pause the video at this time. Read the section first before going on with this video. So to begin with, we want to define pi. Pi is a number that you've worked with before, and remember it is a number. And that number represents a ratio. Okay? And the ratio that it represents is the circumference compared to the diameter of any circle. So when we talk about pi, pi represents the circumference divided by the diameter. So for any circle, if I take the circumference and divide it by the diameter, it will be equal to a number close to 3.14. Okay, but it is a number. Now, when we're using pi in calculations in throughout, whether it's finding the circumference or area or anything like that, you always want to use the pi key on your calculator. The pi key is a much better estimation than just trying to put 3.14 in. So make sure that you do that when you're doing your calculations. Now, if we take what pi is equal to, circumference over diameter, and if we rearrange that or solve for the circumference, we can come up with an equation for finding the circumference of a circle, or a formula for finding the circumference of the circle, and that is that the circumference of a circle will be equal to pi times the diameter, where d is the diameter. Or, since we know that the diameter of any circle is always double the radius, so 2 times the radius, we can also write the circumference of a circle this way. Circumference is equal to 2 pi r. So let's take a look at example 1 here. It says, for a ceiling fan, the tip of the blade travels in a circle with a diameter of 46 inches. For a desk fan, the tip of a blade travels in a circle with a diameter of 6.5 inches. Find the circumference of each circle to the nearest hundredth of an inch. So we've got our ceiling fan, we'll call that CF, and we also have our desk fan, which we'll call DF. And if I'm going to find the circumference of each of those, well, I know the circumference is equal to pi times the diameter. So I'm going to say circumference for the ceiling fan is equal to pi times 46, which as an exact value is 46 pi. But usually when we're working with real-world situations, we want to get an approximation to that. So we would take 46 times pi on our calculator, which is about 144.5 inches. That's rounded to the nearest, well, I'm sorry, it said to the nearest hundredth of an inch, which would be 5.1, excuse me. Now, if I look at the desk fan, the circumference of a desk fan is equal to pi times the diameter. And now the diameter of the desk fan is pi times 6.5. Okay? And if we're going to get an approximation to the nearest hundredth of an inch for that, let's go to our calculator for that one, and that would be 20.42. Okay. Now in both cases they were in inches, so this would be inches as well. Okay, so let's talk about exact versus approximate when we're using pi. I talked a little bit about an example in example 1, but when we're finding an exact value in calculations that involve pi, you need to leave pi in your final answer. So whatever you would just simplify everything except for the multiplying by pi and just leave that in your final answer. Okay? If you are not finding an exact answer, make sure that you multiply by pi with the pi key on your calculator. Now, generally speaking, we can leave an exact answer, or it's generally it's best to leave an exact answer if we're talking about something that's theoretical. It's not a real world problem. However, if we are doing a real world problems, a lot of times it's easier to not easier, but it's more useful if we get a decimal approximation. So generally speaking, real world problems will try and get a decimal approximation, whereas theoretical ones we will not. Now the other thing is when we're doing our calculations involving pi, we don't want to do any sort of, even if it's a real world problem, I don't want to do any rounding until the very end, in which case then we could round to the nearest tenth or hundredth or whatever we're looking for. So we always have to be careful with that when working with approximate answers. The last topic I'd like to take a look at in this section is computing arc length. And basically when we're computing arc length, what we're doing is before, when we've looked at arcs, we've looked at them in terms of their measure, and that was always related to the central angle of the circle. Now we're going to look at what is the actual length or the measurement that I could do, like on a ruler, for that arc. And the way that I can do that is by looking at what fraction of the circle it is, and then taking that fraction times the circumference. The way that I do that then is that whatever the measure of the arc is, okay, so in this case, like down here, it's 50. So I'm going to put that number on top over 360, because that will give me what fraction of the circle it is, and then I can multiply it by the circumference. So let's take a look here at example 3. It says find the exact length of arc PQ. Well, to do that, I'm going to use the formula that I had above. That arc length is equal to the measure of the angle. So the arc length is equal to the measure of the angle, which is 50 over 360 times the circumference. And I know the circumference is pi times the diameter, or 2 times pi times the radius. So I'm going to say times 2 times pi times, in this case, the radius is 18. Okay? If I multiply that together, I will have the arc length for this particular one. Why don't you try that on your calculator at this time? Why don't you pause the video now, try it on your calculator, and turn it back on, and I'll have the answer there for you. So if I do that from an exact value standpoint, I would get 5 pi, 50 over 360 times 2 times 18 gives me 5. So I can leave it as 5 pi, or approximately 15.7. Okay, finally let's take a look at number 4. It says a circle has a radius of 8 inches. A wedge of the circle has an arc length of 8 inches. What angle to the nearest tenth of a degree is formed by the two radii of the wedge? So if that's the case, let's use the arc length idea to go ahead and solve this. So if arc length is equal to the measure of the angle over 360, and then I'm going to multiply that times the circumference. Well, in this case, I'll just leave it as circumference for right now. So then the arc length is, we know, is 8 inches. We don't know what the measure is, so I'm going to put the measure over 360, and then I have to make that times the circumference, which is 16 pi. 2 times 8 times pi. Now, I'm going to leave that one for you to solve. I'd like you to solve for m there, see if you can find what that measure is, and we'll talk about that one in class.